So today we will speak about expectations. So first of all, the notation of expectations is E of x, and it is the same thing as the average value or the mean mu. When we were in grade 6, we learned that the average value can be calculated by adding the values and dividing by the number of the values. Then just last semester we learned that instead of dividing with the frequency, we could also multiply each of the values with the probability of it happening. And as we can see, we would actually really get the same answer even in this small simple case. So the mean value can be calculated as multiplying the values of x with the probability of each of the x's. So expected value can be calculated as multiplying the x values with the probability of each of those values happening and adding that all together. We'll have a look at some of the properties of expected values that we need to know. As you can guess, this would work for all discrete distributions. That's where we count the answers. So I would be 1, 2, 3, and so on, any whole number. For continuous distributions, the expected value formula is slightly different. The expected value can be calculated as an integral from a to b, and again we multiply the x with the probability of x dx. Quite similar if you have a look at it. It's pretty much the same thing, only instead of the sum, we now have the integral. We're still multiplying the x values with the probability of each of the x's happening. So the first property is that expected value of any constant is a constant itself. And I think that makes sense. If we have the expected value of 5, that will just be 5 because that's the only value we really have. The next one, if we have the expected value of random variable x, which is multiplied by c and then d is added, that's called a linear combination. Then what we can do, we can put the c in front, multiply with the expected value of x itself, and add d at the end. How would that look like as an example? For example, if we would want to calculate the expected value of 3x plus 5, we would be able just to multiply 3 times the expected value of x, which probably should be given in the question, or you can just multiply and find it yourself, and we would add 5 at the end. That's a 5. It doesn't look like 5. And this would work each time that we would multiply the x with a number and add something at the end. However, it would be slightly different if we would want to, let's say, find the expected value of x squared. It would actually be slightly different if we would want to find the expected value of x squared. So, as we remember, expected value of x can be found as the sum of all the x's multiplied with their probabilities. Well, in this case, we would need to find the sum of all the x values squared multiplied with the same probabilities as before. And let me give you a small example of that. So, let's say we would have a dice. And instead of having values of 1, 2, 3, 4, 5, 6, our die would have values of -2, -2, 0, 1, 2, and 2. So in that case, our possible values of x are -2, 0, 1, and 2. And the probabilities that we would have for each of those values, so we could have -2 twice, so that's 2 over 6 or 1/3. We could have 0 just once, so that's 1/6. 1 is 1 over 6. And the 2 also appears twice, so that's 2 over 6 as well. So if we would now want to find the expected value of x squared, we would actually need to square, just physically square the x values. So instead of having -2, 0, 1, and 2, we would just have 0, because that's 0 squared, 1, because that's just 1 squared, and a 4, because that's both -2 squared and 2 squared. And the probabilities of that, so probability of 0 has not changed, it's still 1 over 6. The same for probability of 1, But the probability of 4 is actually a combination. It's the probability of -2 as well as probability of 2. So that would be 4/6. So now to find the expected value of x squared, we would need to multiply the x values by their probabilities and add everything up. And if we do that, we just get 0 plus 1/6 plus 16/6, which equals 2 and 5/6. Okay, so now if we go back, what did we start with here? We said that we would be looking at the properties of expected values, and what we see is that if it is a linear expression, we can just open the parentheses, kind of common sense, and it all works. But if it is something like squared, then what we can do, we can only refer back to the original formula of sum of those x's, which we then square accordingly and multiply with the probabilities. So the formula says that if we have interacted with the random variable x in a different way rather than a linear function, then we need to find the sum of those new x values multiplied with their corresponding probabilities, and the probabilities do not change. So those are the three main properties of expected values right here.